For what value of a does the continuous random variable, whose PDF is given by this f of x function, this little piecewise function, have an expected value of 5? Okay? So let's look at this density function. It's 0 most of the time, but when x values are between 0 and a, and we still don't know what a is, we're going to find that out, it's given by 2a minus x over a squared. Now, this is in no way required, but I've done enough random variables that I can recognize this. This is a nice little triangle. So we are flat 0 up to 0 and a. And when you plug in 0, you'll get 2a minus 0 over a squared. So you'll get 2a over a squared. Goes up here. Plug in a, the a minus a bit goes to 0. And it's a straight line. This is an equation of a straight line, even though there's a lot of a's running around. It's a nice little triangle here. And you can see the base is a, the height is 2 over a. Multiply those two together, and a half of that is the area of a triangle. So it really does work. It is a PDF. Now, again, we're not required to do any of that. What we're interested in is what is the expected value of this. But we don't know what a is, so we're going to have to sort of be working a little abstractly. Okay, so we know 5 has to be, well, actually, let's be nice and neat and proper. We weren't given a name for the random variable, so I'm just going to say let's let x be our random variable. That's a pretty standard name. So we want 5 to be the expected value of x. How do you calculate expected values? You integrate over all real numbers x times your density function, which we're told is this f of x. Now, that can be a lot of work, because with these infinities here, this isn't a proper integral, this is an improper integral. But because of our f of x being 0 pretty much everywhere other than between 0 and a, where it's, 2a minus x over a squared, because it's 0 pretty much everywhere, you can actually ignore everything, all the calculation, because you'd just be multiplying by 0 for all values other than the x values between 0 and a. So we only really need to integrate on this little compact interval between 0 and a. And then we'll have x, f of x, but if we're just sticking between 0 and a, f of x is just this formula here. So 2a minus x over a squared. Okay. Now that looks like a lot, but what we can do is we can factor out the 2 over a squared, because they're just constants. Just pull that out. And then we've got x times a, so ax, minus x squared. This is a nice polynomial. Yeah, I don't know what a is, but it's a constant, and this is a lot easier to work with. Okay, I'm running out of space, so we're going to move back over here. So 5 is 2 over a squared, and then I'll leave some space for some optimism. So we had ax. Well, that's going to integrate to ax squared over 2. Minus, what's the antiderivative of x squared? X cubed over 3. So now we just plug a into this and plug 0 into this and take the difference. Although if you're thinking ahead, we don't really need to plug in 0, because you're going to get 0 squared and 0 cubed, and you're going to be subtracting 0 overall. So really we're just going to plug a into this, and we can ignore the 0 bit. So we got 2 over a squared, and then we'll have a times a squared over 2 minus a cubed over 3. Well, a times a squared, that's just another a cubed. We have a fraction here. Let's get a common denominator. 3a cubes over 6 minus 2a cubes over 6. So 5 is 2 over a squared. 3a cubes minus 2a cubes is just 1a cubes over 6. A squareds and a cubes cancel out, just leaving 1a on top. 2 and 6 cancel out, leaving a 3 on the bottom. So 5 is a over 3. Multiply both sides by 3. And there we go. A is just 15. That is the value for this density function that will give us an expectation of 5. A nice little mean value for our random variable that we called x.